All right, we're going to actually take the simple idea of KNN, K nearest neighbors, and apply that to a more complicated problem, and that's predicting the rating of a movie given just its genre and rating information. So let's dive in and make that happen. Let's have some fun with KNN and actually try to predict movie ratings just based on the K nearest neighbors algorithm and see where we get. So if you want to follow along, go ahead and open up the KNN IPython notebook and you can play along with me. So what we're going to do is define a distance metric between movies just based on their metadata. And by metadata, I just mean information that is intrinsic to the movie, information associated with the movie. Specifically, we're going to look at the genre classifications of the movie. Every movie in our Movie Lens dataset has additional information on what genres it belongs to, and a movie can belong to more than one genre. A genre being something like science fiction or drama or comedy, what have you, animated movies. And we will also look at the overall popularity of the movie, given by the number of people who rated it. And we also know the average rating of each movie. So I can combine all this information together to basically create a metric of distance between two movies, just based on rating information and genre information. So let's see what we get. So we'll use pandas again to make life simple. And if you are following along, again, make sure to change the path to the Movie Lens data set to wherever you installed it, which will almost certainly not be what is in this Python notebook. So go ahead and change that if you're going to follow along. As before, we're just going to import the actual ratings data file itself, which is u.data, using the read CSV function in pandas. We're going to tell it actually has a tab delimiter, not a comma. And we're going to import the first three columns, which represent the user ID, movie ID, and rating for every individual movie rating in our data set. So if we go ahead and run that and look at the top of it, we can see that it's working. We end up with a data frame that has user ID, movie ID, and rating. For example, user ID rated movie ID 50, which I believe is Star Wars, 5 stars, and so on and so forth. So if we want to get aggregate information about the ratings for each movie, that's the next thing we have to figure out. So we're going to use the group by function in pandas to actually group everything by movie ID. So we're going to combine together all of the ratings for each individual movie, and we're going to output the number of ratings and the average rating score, the mean, for each movie. So let's go ahead and do that. It comes back pretty quickly. So this gives us another data frame that tells us, for example, movie ID 1 had 452 ratings, which is a measure of its popularity, how many people actually watched it and rated it, and a mean review score of 3.8. So 452 people watched movie ID 1, and they gave it an average review of 3.87, which is pretty good. Now, the raw number of ratings isn't that useful to us. I mean, I don't know if 452 means it's popular or not. So to normalize that, what we're going to do is basically measure that against the maximum and minimum number of ratings for each movie. And we can do that using this little lambda function here. So we can apply a function to an entire data frame this way. And what we're going to do is use the numpy min and max functions to find the maximum number of ratings and the minimum number of ratings found in the entire data set. So we'll take the most popular movie and the least popular movie and find the range there and normalize everything against that range. So what this gives us, when we run it, is basically a measure of popularity for each movie on a scale of 0 to 1. So a score of 0 here would mean that nobody watched it. It's the least popular movie. And a score of 1 would mean that everybody watched it. It's the most popular movie. Or more specifically, it's the most popular movie, the movie that the most people watched. Okay? So we have a measure of movie popularity now that we can use for our distance metric. Next, let's extract some genre information. So it turns out that there's a u.item file that not only contains the movie names, but also all of the genres that each movie belongs to. So this little bit of code will actually go through each line of u.item. We're doing this the hard way. We're not using, any pandas functions. We're just going to use straight up Python this time. Again, make sure you change that path to wherever you install this information. So we will open our u.item file, and then we will iterate through every line in the file one at a time. We're going to strip out the new line at the end and split it based on the pipe delimiters in this file. And we will extract the movie ID, the movie name, and all of the individual genre fields. So basically there's a bunch of zeros and ones in 19 different fields in this source data, where each one of those fields represents a given genre. So let's see what that looks like. And we will construct a Python dictionary in the end that maps movie IDs to their names, genres, and then we'll also fold back in our rating information. So we will have name, genre, popularity on a scale of 0 to 1, and the average rating. So that's what this little snippet of code does. Let's run that. And just to see what we end up with, we can extract the value for movie ID 1, which happens to be Toy Story, an old Pixar film from 1995 you've probably heard of. And what we have in our dictionary is, for entry 1, movie ID 1, the name is Toy Story. This is a list of all the genres, where a 0 indicates it is not part of that genre, and 1 indicates it is part of that genre. And there is a data file in the Movie Lens dataset that will tell you what each of these genre fields actually corresponds to. But for our purposes, it's not actually important, right? We're just trying to measure distance between movies based on their genres. So all that matters mathematically is how similar this vector of genres is to another movie, okay? The actual genres themselves, not important. We just want to see how same or different two movies are in their genre classifications. So we have that genre list. We have the popularity score that we computed, and we have there the mean or average rating for Toy Story. So let's go ahead and figure out how to combine all this information together into a distance metric so we can find the k nearest neighbors for Toy Story, for example. So I've rather arbitrarily computed this distance function that takes two movie IDs and computes a distance score between the two. And we're going to base this, first of all, on the similarity, using a cosine similarity metric between the two genre vectors. So, like I said, we're just going to take the list of genres for each movie and see how similar they are to each other. Again, a 0 indicates it's not part of that genre, 1 indicates it is. We will then compare the popularity scores and just take the raw difference, absolute value of the difference between those two popularity scores, and use that toward the distance metric as well. And we will use that information alone to define the distance between two movies. So, for example, if we were to compute the distance between movie IDs 2 and 4, this function would return some distance function based only on the popularity of that movie and on the genres of those movies. Okay? So imagine that as a scatter plot, if you will, back to our original example in the slides, where one axis might be a measure of genre similarity based on cosine metric. The other axis might be popularity. Okay, we're just finding the distance between these two things. So for this example, where we're trying to compute the distance using our distance metric between movies 2 and 4, we end up with a score of 0.8. And remember, a far distance means it's not similar, right? We want the nearest neighbors with the smallest distance. So a score of 0.8, pretty high number on a scale of 0 to 1, so that's telling me that these movies really aren't similar. If we just do a quick sanity check and see what these movies really are, turns out it's the movies GoldenEye and Get Shorty, which are pretty darn different movies. You know, you have James Bond action-adventure here and a comedy movie, and not very similar at all. They're actually comparable in terms of popularity, but the genre difference did it in. Okay, so let's put it all together. Next, we're going to write a little bit of code to actually take some given movie ID and actually find the k nearest neighbors. So all we have to do is compute the distance between Toy Story and all of the other movies in our movie dictionary and sort the results based on their distance score. And that's what this little snippet of code does here. If you want to take a moment to wrap your head around it, it's fairly straightforward, but like we say, we have a little get neighbors function that will take the movie that we're interested in and the k neighbors that we want to find. It will iterate through every movie that we have. If it's actually a different movie than the one we're looking at, it will compute that distance score from before, append that to the list of results that we have, sort that result, and then we will pluck off the k top results. Okay? So in this example, we're going to set k to 10, find the 10 nearest neighbors. We will find the 10 nearest neighbors using get neighbors, and then we will iterate through all of these 10 nearest neighbors and compute the average rating from each neighbor. And that average rating will inform us of our rating prediction for the movie in question. And as a side effect, we also get the 10 nearest neighbors based on our distance function, which we could call similar movies. So that information itself is useful. Going back to that customers who also watched example, if you wanted to do a similar feature that was just based on this distance metric and not actual behavior data, this might be a reasonable place to start, right? So let's go ahead and run this and see what we end up with. And the results aren't that unreasonable. So we are using as an example the movie Toy Story, which is movie ID 1, and what we came back with for the top 10 nearest neighbors are a pretty good selection of comedy and children's movies. So given that Toy Story is a popular comedy and children's movies, we got a bunch of other popular comedy and children's movies. So it seems to work. We didn't have to use a bunch of fancy collaborative filtering algorithms. These results aren't that bad. And if we just want to use KNN to predict the rating, where we're thinking of the rating as the classification in this example, we end up with a predicted rating of 3.34, which actually isn't all that different from the actual rating for that movie, which was 3.87. So not great, but it's not too bad either. I mean, it actually works surprisingly well given how simple this algorithm is. Most of the complexity in this example was just in determining our distance metric. And we intentionally got a little bit fancy there just to keep it interesting, but you could do anything else you want to. So if you want to fiddle around with this, I definitely encourage you to do so. Our choice of 10 for K was completely out of thin air. I just made that up. How does this respond to different K values? Do you get better results with a higher value of K or with a lower value of K? Does it matter? Can you actually, if you really want to do a more involved exercise, you could actually try to apply to train test to actually find the value of K that most optimally can predict the rating of a given movie based on KNN. And you can use different distance metrics. I kind of made that up too. So play around with the distance metric. Maybe you can use different sources of information or weigh things differently. Might be an interesting thing to do. Maybe popularity isn't really as important as the genre information, or maybe it's the other way around. See what impact that has on your results too. So go ahead and mess with these algorithms, mess with the code, and run with it and see what you can get. And if you do find a significant way of improving on this, share that with your classmates. That is KNN in action. So very simple concept, but it can be actually pretty powerful. So there you have it. And there you have it. Similar movies, just based on the genre and popularity and nothing else, works out surprisingly well. And we use the concept of KNN to actually use those nearest neighbors to predict a rating for a new movie. And that actually worked out pretty well too. So that's KNN in action. Very simple technique, but often it works out pretty darn good.